Hello friends, so I am Divanshu Garg, and in this video you will learn something new about LCM, lowest common multiple. I mean to say that I will explain to you the logic behind the rule of LCM so that it is easy for you to apply. So let's start it. So lowest common multiple. So first of all, let's discuss the word multiple. So multiple of 4, let's say multiple of 4. So all those numbers which will come or which comes in the times table of 4 are the multiples. Or you can understand in this way, when you multiply two numbers or three numbers, whatever result comes is a multiple of those three or two numbers. Okay. For example, 6 multiply 4 is equal to 24. So 24 is a multiple of 6 and 4. Or you can understand in this way, multiples of 4 means 4, 8, 12, 16, 20, 24, 28. So the list is very long. So my purpose is to explain or to tell you the meaning of multiple is that I want to explain to you that how multiple is formed. Because if you understand this one, then you can easily understand the concept of LCM. So what is the prime factorization of 4? 2 multiply 2. And if I need 20, which is a multiple of 4, I need to multiply an extra number, which is 5, in 4. To get 20. Sorry. Okay. And if you get 24, if you want to get 24, so you need to get or you need to multiply an extra number 6 in 2 multiply 2. Means you need this one, but to get a multiple you have to multiply an extra number. The number may differ, it may be 5, 6, 7, 8, whatever you want to write, but you have to write 2 multiply 2, and then you have to multiply an extra number. So this is the thing I want to explain to you, and then let's take two numbers to find their LCM. So let's say multiple of 6 and 20. So first of all, we need to write the prime factorization of 6 and 20, which is 3 multiply 2, and for 20, which is 2 multiply 5. Or you can say that 2 raised to power 2 multiply 5 raised to power 1, and 3 raised to power 1 multiply 2 raised to power 1. So for LCM, according to the rule, what rule says, we have to take all different prime numbers. So in this case, 2 multiply 3 multiply 5. And one more thing, why we use multiplication? Because multiple is bigger than, multiple is always bigger. Okay, like I give you an example, 24. So 24 is a multiple of 6 and 4, and 24 is bigger than 6 and 4. So in the same way, we use multiplication over here. So now the question comes, why we need to write all the prime numbers? Because this method is totally opposite to HCF. In HCF, we only take common prime numbers. But here we take all prime numbers. Why? As I explained to you, if you want to, in this case, if you need to get multiple of 20, means you need this one. You need to multiply an extra number in this portion. Means you need 2, you need 5. Okay. To get multiple of 6, you need 3 and 2, and you have to multiply an extra number. So that's why, and we need common multiple, means multiple of 6 and 20. So that's why we need 3, 2 and 5. we need all the prime numbers. This is the logic behind it. Okay, now the rule says we have to take the highest power of each prime number. So first of all, 2 raised to power 2, 2 raised to power 1, which is highest, 2 raised to power 2. So we will take 2 raised to power 2. 3 raised to power 1, 5 raised to power 1, which is highest, 3 raised to power 1 and 5 raised to power 1. Because we do not have 3 over here in this case, and we do not have 5 in this case. So in one way we can say that 3 raised to power 1 and 5 raised to power 1 is the biggest one. So what is the answer? So 4, 20 and 60. So now let's understand one more thing so that you will understand completely about LCM. This is the lowest common multiple, means there is no any other multiple of 6 and 20 which is lowest than 60. 60 is the lowest one. Okay, this one, so 2 multiply 2 multiply 3 multiply 5. So this factorization, or you can say that this factorization satisfies these two multiples. For 6 we need 3 and 2, so 3 and 2 covers over here, and in 3 and 2 we multiplied an extra number. By using this method we multiplied an extra number which is 2 and 5. So whatever the number comes is a multiple of 6. In case of 20 we need 2 to 5, so 2 to 5, and in this we multiplied an extra number, so whatever the result comes will be a multiple of 20. Now many of you think that okay, why can't we take the lowest power? Let's take it and see the result. Let's take the lowest power over here. So lowest power in case of 2 is 2 raised to power 1, 3 raised to power 1 and 5 raised to power 1. As we do not have 3 over here and 5 over here, so in the same way we can say that 3 raised to power 1 and 5 raised to power 1 is the lowest one, is a lowest power. Or so now if you multiply this one, so this is 30. So we can say that 30 is a multiple of 60, but do you think that 30 is a multiple of 20? No. So in 20 times table 30 can never come. So that's why we always take the highest power, not lowest power. To remember it, what you can do, lowest, what is the opposite of lowest? Highest. It is just a way to remember it. I'm not giving you a method or a word to cramming, but I am explaining to you that why we need to take a highest power. But to remember it, you can do in this way, that opposite of lowest is highest. In case of HCF, we have to take the lowest power. So you can remember in this way that what is the opposite of highest? The word highest, the opposite is lowest. So we have to take lowest power. Okay, and now in HCF we have common word C. So that in this case you need not to think that we have word common in both these numbers. So why do not we take word common? The difference in their meaning. There is a difference in their meanings. LCM has different meaning, HCF has different meaning. So we cannot take the word common as a same. Let's take one more example. Uh, 18 and 60. So 18, first of all 18, the prime factorization of 18 is 3 multiply 2, or 3 raised to power 2, multiply 2. 60, 3 multiply 2 multiply 2 multiply 5. 3 multiply 2 raised to power 2 multiply 5. So now LCM. First of all, what rule says? We have to take all the prime numbers, which is 2 multiply 3 multiply 5. So why? Because if you need to find out multiple of 60, you need this one and you need to multiply an extra in this one. So you need 3, 2 and 5 to get multiple of 60, and to get multiple of 18 you get 2 and 3. So that is why we have to take all the prime numbers, different prime numbers. Now highest power. So 2 raised to power 2, 2 raised to power 1, which is highest, 2 raised to power 2. 3 raised to power 1, 3 raised to power 2, which is highest, 3 raised to power 2. And we do not have 5 over here, so in one way 5 raised to power 1 is the highest one. So if you multiply, this is 4, then multiply 9, multiply 5. So 20 multiply 9, which is 180. So this is the lowest multiple of 18 and 60. So again, why we took highest power? Because if I expand this, 2 multiply 2 multiply 3 multiply 3 multiply 5. So this portion covers in this. So 3, 2, 2 and 5. And we multiplied an extra number, which is 3. So whatever the result comes is always a multiple of 60. In case of 18, so 18 is 3 multiply 2, 3 multiply 3 multiply 2, and in this result an extra number 2 and 5 is multiplied. So whatever the result comes is always multiple of 18. And if you think that, okay, let's try in this one, let's take lowest power. So lowest power, so LCM, lowest power, which is 3 raised to power 1, 2 raised to power 1 multiply 5. Okay, 1, 630. So 30, so do you think that 30 is a multiple of 18 and 60? No, 30 is not a multiple of 18 and 60. Okay, so that's why we cannot take lowest power, because it will not give us an LCM. Okay, why there is so much importance of LCM? The purpose to get LCM so that our calculation becomes easier. Let's say if you have these two fractions, 1 over 18 plus 1 over 60. One way is to get a common denominator for these two. One way to get an equivalent fraction of 1 over 18 and 1 over 60 with the same denominator. Then you can add them together. This is a one way. Another way, that you have to take an LCM. So in this case the LCM is 180. So in this way, so if you find in this way, if you find the LCM of these two numbers, your calculation becomes very, very easier. Otherwise it will take time to solve it if we have bigger number over here. So this is the logic behind LCM, and I think you understand. If you still have a doubt that this step is not understandable or how it is possible, so don't worry, just mention in the comment box and I will explain to you again through a video that why this happens. Okay, so that's all.